Hello, I'm here to talk about Hyperledger Burrow new features. There was a talk by Silas Davies called Boring into Burrow, which covered a lot of things which I was intending to cover here. So this has become a bit of a Burrow Solang kind of presentation. I've combined them two. So first I'll talk a little bit about Hyperledger Burrow, and then a bit about Solang. This is a little bit about me. So I'm working full-time on Solang now. I'm a maintainer of Burrow, and I do maintenance of infrared subsection of Linux kernel as a part-time thing. So I thought I'd go over a few small things of Burrow again. What is Burrow? It's a single binary. So there's one Go source tree. You do with those instructions down there. You can quickly install the Burrow binary, and once you have that binary, you can do everything with that. You can create a genesis, run a chain, deploy a contract. All the features are built in subcommands of that single binary. It supports EVM and EWASM smart contracts, so you can compile Solidity using the Ethereum Source C compiler. And it has a pretty small footprint, so it runs on the Raspberry Pi. FreeStone works fine on mine. So one thing I thought I'd highlight is you can, when you deploy Solidity contracts, you can deploy metadata with the actual bytecode. And our bytecode gets stored on chain, so you can retrieve the metadata for an address. You just say there's a gRPC call, get metadata, and you pass it an address, and it will tell you what the metadata is for that contract. And from that, you can get ABI and other things. So here's a command line tool in our Burrow binary. You do Burrow, just type Burrow account, that's it, and then you get a list of all the accounts that are in your chain, and it'll give you the hash code for the EVM. It gives you the name of the contract and the source file and the compiler version. So with those bits of information, if you have the original source, you can verify that it compiles to the same hash. It'll also tell you what the functions are and what the events it can emit. So it's kind of handy, because you get a bit of insight of what's actually in your chain. So another feature of Burrow is EWASM support. So we've recently added EWASM support using the Perl and Live engine, and that has a ahead of time. It's not actually JIT. It's a ahead of time compiler built in. So it's really quick. And when you do a Burrow deploy, in order to deploy some contracts, you just specify -WASM, and it will run Solang, which will compose the WASM, and it will just be deployed as a WASM contract rather than an EVM contract. The two types are ABI compatible, so you can do calls from EVM, Solidity EVM to Solang on WASM. So some of the things that I haven't gone round to doing, but I've really want to work on really, is because we've got that metadata on the chain, one of the things you could do now is all the transactions which are stored on the chain, you can decode all of those. You can then say, this contract calls that contract, and these were the arguments, and these were the return values. So your chain becomes a much more sort of readable thing, where all the interaction between the contracts is just readable. It would be nice if you could just actually Greg's done some of the work, but if you can call Solidity functions directly from your CLI, as you've listened earlier. Also, Source C now gives you the layout of contract storage. So with that information, we can decode contract storage. So not only can you see transactions, you can also see the current values of all the contract storage variables. And once you have that, one of the things you can do is, if a contract storage variable has an unexpected value, you can put a marker on it and then find the exact point where that variable was set. Those are ideas of things we could do once the ABI, now that the ABI stuff in Burrow is in place. So I thought I'd now talk about Erlang Solidity Compiler. It's a project that started in Burrow, really. We were struggling with various bits of Sol-C, and we started to realize that it's not an efficient compiler. It has certain limitations. So we thought a new compiler might be the best thing to do. So I started this project, and managed to get funding through the Web3 Foundation. And currently, it targets EWASM, Sabre, and Parity Substrate. So EWASM is, through EWASM we can support Burrow, but anyhow, there are also a lot of other chains which support EWASM. So as I said before, Solidity today there is really one complete compiler implementation, and that's the Sol-C Ethereum Foundation compiler. It's a huge code base. It includes a handwritten parser, Lexa, optimizer, the YAL to EVM. So Sol-C compiles Solidity, and the intermediate language is YAL, and YAL has its own backend to target EVM, and that includes an entire optimizer in order to make that possible. So that's quite a large code base, and writing compiler backend is quite a difficult thing to do if you want to generate optimal code. Currently, the EVM output from Sol-C isn't that great. If you've spent any time debugging or reverse engineering Solidity output, you'll see that there's a lot of repetitive, a lot of bits of codes are repeated. You come across bits of code which are entirely unused. So it's not that great. The other problem Solidity has is that it's entirely bound to Ethereum. There are a lot of opportunities to use Solidity on other chains. So there are chains which have very specific properties. Earlier today, I was talking to Mick Bauman about private objects and how you can use WASM to store private objects off-chain. And they have a different interface because it's private, because they are because it's off-chain encrypted contracts. So by having our own compiler, which has different targets, we can target those models. So then we can have Solidity running off-chain, encrypted, and then having a tested results sent back to the chain. With the Sol-C compiler, that wouldn't be possible. There's also Fabric, which has its own WASM model, and that can also be supported by Solane. Okay, so a bit about the project and the basic ideas behind it. So it's entirely new code base. It doesn't share any code with the Ethereum Foundation Solidity compiler. It's written in Rust. It has a generated parser. Turns out that Rust is quite a suitable language for this. In Rust you have enums, and those enums map very well to the AST, for example. So AST is quite short, And walking AST can be easily done with various traits and impulse on the AST. So it makes the code base very short. So once it's parsed and resolved, we generate LLVM IR, and then we hand it off basically to the LLVM libraries. So you give the LLVM IR to LLVM, and you specify what target you want, and then there's a function which basically does sort of make it happen and runs all the optimizations and hands you back the optimized byte code. And LLVM being a high-quality compiler, you get very well optimized code. So Solidity usually uses the ABI from the Ethereum Foundation, the ETH ABI. For parity substrate, uses a different encoding, which is much more efficient. It uses, for a byte, it just uses 1 byte, not 32 bytes, for example. So in the WASM, it has to do the decoding for the ABI calls and encode the return values. So it has code gen for both the ETH ABI and the Scale ABI. So Solang isn't complete yet. The features which do work, so for the types, we have most of the basic types. For the types which are missing are dynamic array strings, bytes, and mappings. Those are underway. They're sitting on my laptop, and they'll be finished. They'll be finished this month. For the grant from the Web3 Foundation, there's a roadmap, and that's expected to complete in fall, and then we'll have full language support. Because we're compiling to WASM, not EVM, not everything can be supported, which is supported in Sol-C today, because in Sol-C you have an assembly statement where you include some EVM instructions, and if we're targeting WASM, then those instructions obviously don't work. Also, EVM instructions are supported in Sol-C. Assembly statements are supported in Sol-C because in EVM model, there are specific instructions to access on-chain information like block height or block hash. In the WASM model, those are host functions, so you wouldn't want, there's no need to support assembly instructions in the WASM model. You can access all the chain information via host functions, not via instructions. So there are various ideas of where this project should go beyond just having Solidity to WASM compilation. So one thing is target support. So Fabric is one which I've had various conversations about today and yesterday. There's some obvious features which you want in Solidity language in order to make the language better. So one is arithmetic overflow. The string processing in Solidity is poor. If you want to compare two strings, for example, the advice you find if you Google that is the hash both the strings and compare the hash. There's no way of doing concatenating strings and so on. Arrays, in-memory arrays don't have a push and a pop. All these things are relatively easy to support, especially on WASM. So they do make a lot of sense to add. It might be another feature which is actually larger would be to have a generic type system like TypeScript, so you can have various collections of types, which is kind of hard to support in Solidity as it exists today. Another thing you can do.
What would you call that language? That would be a Solidity++.
Well, just Solidity, but better.
I mean, like Haskell, GCHI have a word like
Yes, you'd want to add them in a way which is compatible, so you don't break any existing code. One of the problems that I've had in the past is that the Ethereum Foundation Source C compiler, they don't seem to be particularly happy accepting patches if it doesn't fit in with the way they're thinking. So it would be better to have a more of a standards body involved in this. But yeah, if that's possible, I don't know. I would certainly want to work with that if that's possible. Possibly you could have something in Hyperledger to define what the Solidity language should look like. In Solang, in order to support the various things you can do in Solidity language, sometimes it's easy to generate IR, but sometimes it's generating IR is just too much code. So the other thing I've done is some of the functionality is implemented in C, and with Clang that's compiled to WASM, and then during linking, the generated IR and this is compiled to C is linked into the final contract. So you have something like a standard library for Solidity. And that could be extended in various ways. So you could have a much larger and richer standard C library. The great thing about the way this is done is that it's not actually compiled, the library isn't actually compiled to WASM directly. It's compiled to LVM IR, and then the IR from the compiler and the IR from the standard library is combined, and there's link-time optimization is done over both of those, and the functions which are unused, etc., those are just thrown away. So through dead code elimination. So the resulting WASM code, it doesn't get big if you have a bigger standard library. But there's a lot of things that could be added there. One of the things that spring to mind is things like string formatting, all the things you want to do with strings. Another thing would be useful is to have a nice Solidity language server. So when you're typing in your VS Code or whatever IDE you use, you have syntax highlighting, you have various, if you have over symbols, you get definition of the symbol. And that's done through a language server. It's simple binary that runs, and JSON messages are exchanged with it. So because Solang is already parsing and resolving Solidity, it would be a question of wiring up those things to make it work as a language server. You can extend that even further, so you could have a linter, or I think something like Rust Clippy, which will give you loads of hints of how to improve your code, or things that are dangerous but not necessarily invalid. We wanted like a Solang playground and debugger. You might want, if there's a web interface for any particular DLT, then you might want to include an IDE in the web interface directly, so you can write Solang Solidity in that web interface. So these are the various things which are good ideas. So the idea of Solang, what it should be, is like a Solidity language toolkit. It's a set of code, which is a library, which can be used to process Solidity in various different ways. You can imagine if you want to apply formal methods on Solidity, you don't want to start by writing a new parser. It's too much effort. So being able to reuse some of this code with a nice interface would be very useful. So that's it. Thank you. So. Yeah.
And I've spoken to about Blackburn. What would be the way around that? Like, is the best thing, like, can you transpile it to like WASM assembly, direct calls?
Yes. So in the case of the proxy, in the case of the proxy, if you have one contract which forwards a call to another contract, and you want to access the call data and pass that on to the other contract, and when what the other contract returns, you want to pass to the calling contact, the contact that calls the proxy. In Solidity, at the moment, you can only do that via EVM instructions. But what you could do is, if the fallback function takes a raw bytes argument and also returns a raw bytes value, then you can directly just call the other contract and pass it back. So I think for most of these cases, you're using EVM because there are limitations in Solidity language. So I think if you improve the language a bit, then you don't need those EVM instructions. The only problem you still have is you still need to fix up code.
And could you do a mapping of EVM instructions to WASM, how big of an undertaking that would be? Like, not even a like dynamic, just a converter.
Yeah, it wouldn't be, there aren't that many which are commonly used, so you could have a subset of those instructions you could support. That's certainly possible. It's, if you do a subset, then you wouldn't necessarily be sure that the way you're translating is correct. But you could easily do 90% of the cases or so. You could do fairly easily, I think. There are various, one of the things, when people do an assembly block, they often do things like get the top, the free memory pointer. Because in Sol C and EVM, you have like a single stack for memory. And in the WASM model, that's not true. With Solang, there's like a little heap where you can malloc and free arbitrary. So some things just don't translate literally very well. They have to need to be transpiled somehow. One of the reasons that you can't do push and pop on memory arrays in Sol C is because it doesn't have a proper heap. And if you would sort of push a number of objects onto an array, it would cause reallocs, which would just overflow its memory model too quickly. So actually moving to WASM opens a lot of opportunities to make the language better.
Well, I've got another question that's about that. So CSL, Virgo, Downward, like, it has a certain mind share in theory, and that's maybe it's not wholly. But I wonder whether it could become like a dirty code language. Right, so if we had this strong interrupt with being able to link into other WASM libraries, call up code, it might be that your Virgos would just don't want to go to their hands with kind of general new code, kind of like Bash or something. Like Bash with a D-Web or some kind of notion like that, where actually it would be a nice enough language to interrupt with other things, and it's got the kind of address model that things do. What possible directions would be interesting to? So I think, like, what would be interesting to a non-Solidity interested person?
Well, you can imagine that there's more stuff that's being compiled to WASM, but does not know anything about being on-chain. So you could take a WASM library and link it to some Solidity, and Solidity does the interaction between the chain side and the WASM library. It does the kind of on-chainy side, the glue there. That's one way of doing it. I guess the other way of changing this is Greg has just started a really interesting idea where he's started working on the lexer and the parser, so to parse Viper. And Viper does it does share a lot of things with Solidity, and it turns out that getting something basic working isn't actually that hard. So it could also be used as a model of support for another language. So you can imagine a new compiler based on this work for another language, I think. Not necessarily in the same code base. It could be merged in, or it could be just a whole new project, whatever makes sense.
Can you talk a little bit about the kind of object mapping, object binding? And I know that the JavaScript binding to WASM, there's a lot of code that has to map between JavaScript objects and map them into structs on the WASM side.
Yeah.
How does that work in the Solidity world?
So when you call a contract, you pass in a byte array, and that's ABI encoded arguments, and it's well specified the function you're calling and what the arguments are. The layout of that data is defined by the what's called the ABI file. So in Solidity, when you compile a contract, you get the bytecode and you get the ABI file. So the ABI file specifies how that's encoded. So before you call into the WASM module, all the data is packed into this byte array, and that's passed literally into the WASM module. And then, as a part of the output of Solidity of Solang, there's some code that decodes it into LLVM structures. So in some sense it's similar.
I mean, for example, what size heap would you give the WASM code?
Oh, well, that depends entirely on your how much you're allocating. If you compile a contract that doesn't use any heap, well, you still need you need some stack space. Yeah, and 64K will. So in the WASM model, everything's done by blocks of 64K. So for the smallest contract, you could do 164K page would be more than enough. There's a simple example in the. I can't really. I have. Hard to use one there. I was trying to show this contract. It's it just has a single bool, and this compiles. Well, when I looked at it, it was compiled to 700 bytes of WASM, and it doesn't use any heap. It just needs 64K of. So it depends on what you're doing.
What's the status of WASM support in Fabric?
Okay, so in Fabric there's a labs project called Fabric Chain Code WASM, and that's still in experimental stage. It's a labs project. So that's going on. At the same time, there's also a Fabric private objects project started, and that's also going to be using WASM. That's also early days. I've been talking to them about that.
I remember with Borrow, we called the EVM before the call context, so like, so effectively there might be support by Borrow integration, so like we stay at it. I think effectively do that.
Yeah.
Thanks.
Thank you.